All right, guys, welcome to your integral rules review notes. Once again, this is going to be a pretty quick touch and go video just to kind of give you an overall view of what we did when we talked about integrals, not meant to take a long time. I want you spending most of your time on the worksheet that I'm providing. So in this little video, we're going to tell you what's in this note sheet. We're going to review real quick what all the integral rules are. We're going to talk about the two types of integrals, definite versus indefinite. We're going to talk about the steps for U substitution. We're going to talk about general solutions versus particular solutions for differential equations. We're going to talk about implicit integration and slope fields. All right, so first of all, you guys want to know all the basic rules for integration. There's power rule, the constant rule, trigs, arc trig, logarithm, exponential. Then there's a special strategies like splitting the numerator, long division, and completing the square. So at this point, I want to reference you guys to our special resources for this week. I'm giving you guys three things: flashcards, a reference sheet with all the integral rules on it, and also a little sheet, which I've shown you now for the third time, how to know what integration strategy to use and when to use it. So first of all, let's take a look at the integral rules reference sheet that I'm providing you guys. Basically here, I provide you with all the rules. How to integrate a constant, you just put an x next to it with a plus c. Power rule, add 1 to the power, divide by that number. Don't forget your plus c. Here's all the trig integrals. Here's all the functions that when you integrate them result in arc trig functions. Here's the natural log, and here is the integral of an exponential function here. So these are all the basic integration rules. Also, I would encourage you guys once again to use the flashcards here. I've pre-made a ton of flashcards for you guys. If you just print this out, setting your printer to do front to back printing, the first page is the question, the second page is the answer. And so if your printer prints it out front to back, once you flip this over, you should have this answer on the back of it, and that'll help you remember how to do your integrals. You can also just print them out and glue the pages front to back and cut it out yourself. But there's all of your integral rules, and I would encourage you guys to print that out and use that regularly until you've got them all memorized very well. Finally, another resource I'm providing you guys with in this week's materials is just how to know when to apply each strategy. Now, you already have these notes in your 2.12 in your notebook. So right in this handout here, it's not filled out, but if you guys go to your notes, you can look at it. It's more filled out with some examples, but it tells you how do you know when to use each strategy. Like when is it a natural log? When is it a reverse power rule? Because they actually look very similar. Or how do you know when it's an arc trig? How do you know when it's a completing the square problem or a long division problem or splitting the numerator problem? Now, all of these problems here, you're going to see examples of these, so I'm not going to spend time explaining them now, but you'll see examples of all of these in the worksheet that you're going to be going through. But I'll let you guys go ahead and return to your 2.12 notes to kind of see what the examples look like. But at that point, we're going to go ahead and continue with the regularly scheduled program here. So first of all, let's review the two types of integrals. You have definite integrals that look like this. They have a number here and here. They have a function here called the integrand. And then they have this, which is the variable of integration. In this case, it's x. And what these ones tell you is they give you the area under the curve, so to speak. And you can solve them with the fundamental theorem of calculus, where little f becomes big F, and you can go ahead and use the fundamental theorem of calculus. I'll put FTC for that. That's a definite integral. Now, an indefinite integral is one where you integrate a function, but there's no limits on it, and the result is another function with a constant added to it. Okay, and this is what we call the indefinite integral. It's where your integral just gives you another function answer with a plus c. This one is one where you get a number answer and it tells you the area under the curve. Those are the two types of integrals that we're working with. Now, in this particular case over here, this is what we call an antiderivative You could also call it a general solution. And as soon as you find the C there, then it's what's called a particular solution. And we'll talk about that more in a little second. But there you go. Those are your two main types of integrals. A lot of times when you're doing integration, you're going to have to do u substitution, and these are the steps. You have to identify your u. Then you find the derivative of u with respect to x, and you solve for dx. Then you plug everything in. Everything that's an x, you're going to replace it with a u. Then you're going to integrate and back substitute. Once again, you're going to see tons of examples of this in the notes. So I would say come back to these steps anytime you're doing a u sub problem to make sure that these steps kind of make sense to you. We've already kind of hinted at general solutions versus particular solutions, but what do we mean by solution? The solution to a differential equation, and what is that? That's an equation with a derivative inside of it, is called a general or particular solution. All right, so for example, here is a differential equation. If I told you y prime equals 3x squared, this would be a differential equation because it's an equation that has a derivative in it, right? Now, the way that you find a general or particular solution is you're going to integrate it. So if you were to integrate this y prime with respect to x, then that means we're integrating 3x squared, right? Because y prime is 3x squared. And the integral of 3x squared is x cubed plus c. And this is what we would call the general solution. It's just the antiderivative, basically. So how do you find the solution to a differential equation? Just integrate it, and you get the general solution. Now, to find the particular solution, you need something called an initial condition. And what an initial condition is it's where they give you some input and its corresponding output. So like let's say f of 0 equals 3. And in that case, what they're doing at that point is they're telling you the x value and the y value. You can just plug the x value in for the x, and you can plug the y value in for the y, and then you can solve the c. And once you find c, that's what we call the particular solution. And so that's what they are. So basically, if you integrate a differential equation, you get a general solution. And if you plug in an initial condition to that to find c, you end up with the particular solution. So that's particular versus general solutions. All right. Implicit integration. This is a very important topic. You're going to see a ton of these in your FRQs this week. But basically, anytime you have some kind of a differential equation, I think I'm writing this backwards actually. Let me clear that out. You first of all would want to get everything with a y on one side and everything with an x on the other. Then you would integrate both sides. And then you're going to find c using your initial condition, and you get y by itself. So you're going to see a lot of questions like that. Very important one. Big point value on your FRQs. The last thing we'll talk about is doing differential equation. Slope fields. Now, slope field questions come in one of two forms. On your guys' worksheet for this week, numbers 23 through 26 are some slope field questions. And what they're doing here is they give you a slope field, and your job is to find which one of these differential equations go with this slope field. And the way that you do that is by looking for if you have a parallel row, like let's go ahead and take a look at our sheets here and see if I can find one. Like 24, for instance. Notice how all of these slopes in this row are the same. Anytime the row is parallel, that means the x has no effect on the equation, because as x changes as we go from left to right, the slope doesn't change. So my derivative has no x in it. So in other words, I know it can't be this one because that has an x in it. So it could be any one of these other ones here. The opposite is true also. So let's add that note here. Parallel rows means no x. Parallel columns means no y, because that would mean that if all of the variables in that column are the same, then the y has no effect on it. Like here, for instance, all of these slopes in this column are the same. Therefore, our differential equation cannot have a y in it. Right away, then we know the answer has to be C for this one. There's other things, though, you could do to match a slope field to its differential equation. You could look for the zero slope. So, for instance, on this problem here, it looks like anytime x equals 0 on this y-axis, the slope is 0. Well, that would happen here. If you plugged 0 in for x, you'd get a slope of 0. Same thing here. These would be undefined. So now I know my answer has to be either A or B, because these are the ones where if you plugged in 0 for x, you get a dy over dx for a slope of 0. So that's another way you can tell. Finally, if those three strategies don't work, just plug in a point. And really what you're trying to do there is look for positive or negative slope. So for instance, right now, going back to the one that we just had, I know that it's either A or B. So what I would do is I would pick, like, let's say this point right here. If I plug in 1, 1, and as you can see, I should get a negative slope. So if I were to plug in positive 1, negative 1 here, positive 1, positive 1. If I plug in positive 1 and positive 1 for x and y, would I get a negative slope? No. If I plugged in positive 1 here, would I get a negative slope? Yes. So now I know this has to be the answer, because that's the one that would give me a negative slope at 1, 1. So that's another thing that you can do. So you can rule out some options by looking for parallel rows, parallel columns, and also zero slopes. And ultimately, if that's not enough to get the answer, you can always just plug in some points and see, does it give me a positive or negative slope like it's supposed to? Now, another type of question, which unfortunately is not on this worksheet that I'm giving you guys for this week, but it is another type of question. You might see it in the FRQs for the week, though, is instead of matching the slope field to the differential equation, and as you can see, these are all differential equations down here because they have derivatives in them. But another thing you can do is you can match it to a general solution. And so to do that, basically you just match the shape of the function to the slope field. So for instance, let's take a look at this worksheet here. If you were to graph this one here, it kind of looks like they're following like a parabola shape. It's a sideways parabola, which would mean that it's going to be a y squared of some kind. Okay, so that would be the general solution, though. Now, it's not any of these because these are derivatives. But, you know, so the other thing you could do is just, like, for instance, look at the shape. If you follow the slopes and it looks something like this, then you think, oh, well, then that one must be a sine function of some kind. So instead of matching it to the derivative function, you could match it to the original function if they give you those options. But those are the two main types of questions. Another type of question that they ask a lot of times in FRQs is they actually just want you to sketch the slope field, but that's a little bit tedious. We're not going to go into that right now, but there you have it. So that is slope field, and I believe that ends our discussion for the day. So just want to review all those basic things with you guys about all these things pertaining to basic integral rules. And so from here on out, we'll go ahead and end it and let you guys work on your worksheet.